Hi and welcome to Programming Percy, and today we will be talking about Kubernetes. If you're a software developer, you probably heard about Kubernetes by now. I hear about it almost on a daily basis, and Kubernetes has really taken over the industry. It's the leading orchestrating tool by far. And when I began learning Kubernetes, it was hard. There were so many terms that I almost gave up immediately. And I came back trying to learn it and I gave up. And for this reason, I will, in this tutorial, try to walk you through Kubernetes slowly and thoroughly, and hopefully we will take it step by step and really understand it. We will be building a simple application. We'll be building an API along with a database, and I hope and aim to help you familiarize yourself with Kubernetes and learn some of the basics and learn the general language for Kubernetes, and I really hope you will enjoy. So what is Kubernetes really? Kubernetes is a tool to help you manage and control containerized applications. If you're unfamiliar with containers and Docker, I suggest you view my video or read my article about learning Docker. Kubernetes is also known as Q8, so if I ever reference it as Q8, I'm talking about Kubernetes. Kubernetes aims to solve the deployment and the control of multiple containers across your infrastructure. And it's developed by Google. You might have heard of them. Kubernetes allows us to have a bunch of features. Kubernetes helps you with service discovery. It exposes your containers using DNS and makes it possible for these services to find each other. It helps you with load balancing. If one of your containers has too much traffic, it can distribute the traffic to another similar container. You have self-healing containers, so if they were to crash for whatever reason, it helps you restart and remove them. It helps you with secrets and configurations, which makes it basically very easy to store secrets for your deployments. And it also helps you with monitoring. It has built-in monitoring for your applications. To give us all these features, Kubernetes composes of a lot of components, basically, that runs and work together. I'm just going to talk quickly about all the components inside Kubernetes to give you a understanding of what everything is. So when you run a Kubernetes cluster, you usually talk about the control plane. And the control plane is responsible for exposing an API. You can see the API here. It's used for accessing and managing the cluster for the admins. You have etcd, which is basically a key value storage for Q8 to maintain the cluster data. You have a scheduler, which is used to check for new pods. We'll get into what pods are soon. Basically a running container. And find a home for these containers to run on. And you have the control manager, which is responsible for managing something called controllers in Kubernetes. And a controller is basically a loop that runs and checks a certain state of the cluster and tries to regulate that state. To manage the containers, so Kubernetes is meant to run pods, which is done by having worker nodes. So you have nodes that basically each of them are running what we call a kubelet. A kubelet is responsible for accepting instructions from the control plane. So one node is running the control plane, which controls the cluster, and that control plane can tell a worker node that, hey, you have to do this or that. And this is all managed by setting up a kubelet. So you have the control plane running, which manages the cluster. You have multiple kubelets or worker nodes that can connect to the control plane, and I think that's a super simple explanation of the whole Kubernetes infrastructure. You will get more familiar with each of the different steps as you follow along in the tutorial, but I just want to mention these words so that you have heard them before. So as you see here inside the node, each node runs a set of things. And we have something called pods. And a pod is a set of running containers. So not just one container, it can be many containers, but usually it's one container per pod. And the node is basically a working machine. You have something called replica sets. Replica sets is used to ensure that there is always a set amount of pods running at the same time. So you have a node signing up to the control plane saying, hey, I'm a worker node, I'm running this cluster as well. And the scheduler says, hey, you're supposed to run 5 APIs of this software we've built. This is the container, run 5 instances of it, and that's known as the replica set. And you have deployments, which are updates for the replica sets and pods, and jobs and services. We'll cover jobs and services shortly. Basically, a service allows pods to communicate with other pods in the cluster by exposing ports. I don't expect you to know all the words. I just want to have you heard them before, so you know when we talk about them later that we're referring to this. Before we begin working with Kubernetes, you actually need to install a few tools. Firstly, we need to install Kubernetes, which you can find instructions to on their website. If you go to their website, kubernetes.io, you can find install instructions for each and every operating system. If you're using Windows, make sure you have VSL. It can be quite tricky, or when I installed it on my Windows, it was pretty tricky getting it running on Windows. Anyways, once you've installed Kubernetes, can't start working directly, but we also need a tool called Minikube. And as stated here, it's a local Kubernetes, which makes running Kubernetes locally a much easier process. I can't stress this enough. Use Minikube when you're developing on your local machine. It's very easy to install. You have the installation instructions right here. You can press whatever buttons you're using and hopefully it's supported. And then we also need Docker. You can visit the Docker website or go to my article about it where I also explain how to. And lastly, we need Golang. We will be using Golang for our API. And Golang is also very easy to install. You can go to go.dev, download, and see if your operating system is supported. Installing all these tools can take some time the first time, so make sure you visit these websites. I'll put the links in the description so you can have them there. Come back once you've installed them. I won't explain how to install them because they're really well documented, so hopefully you can follow along. So it's time to start familiar ourselves with Kubernetes. And as previously mentioned, we will be using Minikube to start and run a local node on our machine that we can use to develop applications. The way, if you've installed Minikube properly, you can do Minikube start. As simple as that, and it will begin starting up a cluster for you to work on. Once that's ready, that can take a pretty long time. So if you're running this for the first time, it's probably a good idea to go grab coffee and come back in a few minutes. I'll do that as well. So welcome back, and as you can see, my Minikube has started up a few components. You can go ahead and run kubectl get nodes, and you should be seeing the Minikube node appearing and that the control plane is running. We will be needing a Docker image, so I will be making a kube demo folder and going inside of it. Maybe I'll go inside of it. Right, so we will begin by building a Docker image. We need a Docker image to run. So let's create a super simple HTTP server using Go, and we will attach a Docker file that builds this server. So I'm gonna go ahead and open up the newly created folder. And I will create a new file called main.go, and we will have the main package. There's a go update. Amazing. I'll do that later. And let's go ahead and do the main function, and we want a very easy API. So we will be using the HTTP standard library, hosting on the root, and we will attach a HTTP handler. So we want the response writer, and we accept a request. And basically we will use the fumpt package to simply print a hello. So a hello gopher. So once people visit our root website without anything added to the URL, they will see hello gopher being printed. We can go ahead and add a second. Let's do alligator, and it will say hello Mr. Alligator. And we need to serve this web page. So HTTP listen and serve. We will do it on port 8080. Yikes, hard-coded ports. But let's start here. So once you've created this inside your main.go, you can do go mod init. I will create a short cube demo. And so I've initialized a Golang module with tidy to clear up any import statements. And this is basically what we need. This is a super simple HTTP server written in Go. But we need to build a container. We can't just use a Go program. So let's create a Go file. I'm assuming you're somewhat familiar with Docker. If you're not, you can watch my video about Docker. And I'm not assuming you're familiar with Go, but I'm assuming you'll find this fairly simple to understand. Basically, main package is what is executed when you start the program. HTTP handle function accepts a URL followed by a function to execute. Fumpt fprint is used to return a response to the visitor. So the input parameter w is a response writer, which allows us to print text to the user. Log.fatal will print a fatal log and stopping the program if HTTP listen and serve would throw an error. And HTTP listen and serve will run forever. So this small program will start up a super simple API with two fairly simple endpoints. So we want to build this program. So let's go ahead and go. We will build an Alpine. We will use the from builder. Workdir-app. And we want to copy everything from our folder into that one. And I will disable some stuff to our builder. This one will disable cgo. It's so that our Golang program can't run cgo, which is used to run C code, but we don't need that, and you save a lot of store space by doing that. So the command we want to run is go build output hello gopher, which is the binary name, and we will add a few LD flags. And we want our small container to start this API for us. So we have a super simple Docker file. It builds a Golang binary, it runs that binary. That's about it. One thing before you build this image is that you need to make sure that you are using the Minikube Docker environment. This is very common to see people forget. Minikube has its own Docker running, which means if you build an image on your local computer, it will build that image to your registry. It won't build it to the Minikube registry. So you actually need to go ahead and you can do Minikube docker-env, and you will see it prints a few environment variables, and you should see this to point your shell to Minikube's Docker daemon. So go ahead, copy that statement, and make sure you run it before you build your Docker image. So if I do Docker images, I'll see I'm now inside the Q8 cluster. These images I don't have locally. They are only on the Minikube Docker daemon. Don't forget to apply that so you're in the right Docker environment. So when we're in the right Docker environment, we can go ahead and do docker build, programming, Percy, hello Gopher, tag it, and use the current context. So now we're building our image, adding it to the Minikube Docker daemon. You need the Docker image to be built so that you can tell Kubernetes to use it. So that's why we're creating a Docker file, if I didn't mention that. Wait for it to download and install, and then we're ready to get cubing. So we have everything we need now. We have Minikube, we have Kubernetes, we have Docker, we have an amazing HTTP server written, and we have built our Docker image. So it's start to build our first Kubernetes resource. In Kubernetes, you use YAML files to define Kubernetes objects. All parts of your application is known as objects. And there's a ton of things you can define in these YAMLs, but we will start very, very simple. So let's create a file named hellogopher.yaml. This will contain everything we need to boot up the API container inside Kubernetes. So there's a few things you need in every Kubernetes YAML. There's a few defaults, and they are API version. This is basically always the same, but you need it. API version lets Kubernetes know which Kubernetes API you're using to create the object. And you have to tell Kubernetes what kind of Kubernetes object you are deploying. And this comes down to the previously mentioned stuffs as deployment, service, and other stuff. There's a bunch of kinds you can use. The kind dictates the rest of the YAML file. So different kinds, so a deployment have a few fields in the YAML that is required. A service have other YAML fields that are available. So you really have to specify the correct type. In our case, it's a deployment. Why we want a deployment is because we're creating a deployment that will boot up a pod running the API. And this deployment will make sure that we create the correct objects, the correct replica set, and it will make sure that the state that we specify in the YAML is maintained correctly. Before we move into that more, the last field is the metadata. This is data that helps us uniquely identify this certain object. This is important. We will name our deployment Hello Gopher. This will make Kubernetes know that whenever we say Hello Gopher and we're talking about a deployment, this is the thing we are talking about. Finally, we'll begin talking about the spec. The spec is the specification, and it's a field that lets the Kubernetes know the state that we will desire. And the spec will change depending on the kind that is selected. We're creating an object, we're creating a deployment that is used to specify the desired state of our pods, and we can also specify replicas, environment variables, default settings about running pods, and whatever. We will begin with specifying the spec, as said. Boink. We will specify a selector, maybe I should write a comment so you can see also. So this is the state you desire for this object. We will be specifying a selector. A selector is a label that can be used by the deployment to find pods that are related to this deployment. And this is very important because we use the selector to reference it when using the kube command line. So let us add the selector, and we will add a match labels. And match labels is basically a map, key value map of pairs. So we will add, the application is called Hello Gopher. We will add replicas, and we will say that we want one replica. Basically, replica is how many identical containers to start. If we set this to 1, it will start 1 container. If we set it to 3, it will start 3 containers. And later on, when we define that it should keep the containers alive and stuff, it will make sure that we always have 3 containers running. In our case, we use 1. Next up, we will define something called the template. The template is a template that Kubernetes uses when deploying and creating new pods. So basically, whenever we create a new pod, when Kubernetes creates new pods, follow this template state. So it's important to remember, we will in the template define the settings for the container. So again, we will add a metadata field, and in this case we will only add a labels. Labels, again, we will do Hello Gopher, and I think that's the only metadata we need right now. Labels are important because you need them when you're searching and managing the deployment. We'll go into labels much more in detail very soon. So a template contains its own spec. I hope you see a pattern here. We're creating an object. This is how an object should look. Again, we're creating an object. This is how an object of the deployment kind should look. So the spec that we're creating is that we will have containers running, and our containers will have the name Hello Gopher. This is the name of the containers that will run. You have to specify the image to run, and this should match what you built the image as. So in my case, Hello Gopher 1.0. Oh yeah, one thing to mention here, don't use the latest tag. Never. It can mess up pretty badly. I mean, if you deploy a software and you use the latest tag and then that image is updated in some way, it can break your code because you used the latest tag. Also, if you use the latest tag, it will kind of check Docker Hub, but you don't want that because we want to check our Minikube registry. So don't use latest tag, and we will also set the image pull policy. Image pull policy is a way of telling Kubernetes how to handle if it doesn't find the image. If we don't find the image, what should we do? And we will use the if not present policy, which basically tells Kubernetes, don't check Docker Hub, check our local registry first. If it isn't found in our local registry, find and check Docker Hub. Right. So we're almost done. We need to tell the containers that they are supposed to expose a port. Remember that we hard-coded a port in the Golang application. So let's tell it that container port is 8080. This will tell it to expose that. Now, I hope this makes sense now. We have created a YAML file that basically defines what our deployment should look like. We have said that this is a deployment named Hello Gopher. We set the specification for this deployment, and we told that deployment has a label that is hello gopher. We are supposed to run one replica of it. We are supposed to use this template for that replica. So every replica that is created should follow this template. And we tell it that they should be containers with label hello gopher. I'm using it the same here because I want to manage them all in the same way. And we say that this is containers, they should run this image, and they should expose that port. And don't fetch it from Docker Hub. So now you've created that. Now it's time to tell Kubernetes to use this YAML to actually build this. And we can easily do that by, let's clear this and do kubectl create, because you want to create this resource. We use the F flag. Can you guys even see? Should I zoom in? Let's zoom in. Let's have a bigger size. So we're using the F flag, and we're telling it to use the hello gopher YAML. kubectl create is used to create resources, and the F flag points out the file to use. So run that, and we had some error apps version 1. Did I misspell that maybe? Oh yeah, sorry. You shouldn't, sorry about that. You shouldn't have a slash there. And we can also see my editor now understands that this is a, so now everything's good. So let's clear it, let's rerun it. Oh, there's a second. Unknown field, image pull policy. Image pull policy. Alright, sorry, my bad again. Right. So, yeah, I can mention that there's a Kubernetes plugin for VS Code that helps you with the syntax. I should have noticed. YAML is very kinky on the inlining. So these fields are part of the containers, so they should be aligned with it. If you have the VS Code, it will tell you information such as, okay, you're using the right API version, and as you can see here, we will cover this shortly, but it says we have something that we really should fix. Right, so let's clear it again and rerun it, and you can say deployment.apps/hello gopher is created. And we can inspect this deployment now to make sure that everything is actually running as we should. So you can do kubectl get all. And kubectl get all is used, let me pull up a real kubectl get all is used to actually show you all the resources that are running across all namespaces. We haven't covered namespaces yet, but we will. So we can see all the resources that exists. So we can see that we have a deployment, we have a service, we have a pod, we have a replica set. And you can see information here that we have desired one, we have one, and one is ready. And this refers to the pod that is running. If you go here and you see image pull in the status, then you're not using the Minikube Docker environment, and you should go back and make sure you eval the Docker env. So have errors, other errors, you can actually get those by doing kubectl get deployment/hello gopher output YAML, which will print a bunch of stuff. In our case, it was successfully deployed, but if you have some kind of error, you can use this command to kind of detect what's going on. So you might be thinking, we're running a API now, so you should be able to visit your local host and seeing it, but that's not entirely true. To reach the application, you need to expose this port from the cluster, because it's running inside the kubectl cluster, right? So we're going to expose something called a node port. inside the HTTP server, we hard-coded port 8080 to be exposed. But we also need to tell Kubernetes that this has to be done. So what we can do is we can use the kubectl expose command to tell it that we have a node port that we want to visit. So we can clear the screen and we can do kubectl expose, and we want to expose something from a deployment, and the deployment is named hello gopher, and the thing we want to expose is of type node port, and we want it to be port 8080, right? So expose something from a deployment, and the deployment is named hello gopher. We use the type node port and port 8080. And you can see service hello gopher exposed, and you can go kubectl get all, and you'll see there's a new service being exposed. So you can see a dynamic port being created. This is the port on my local machine, which maps into the port 8080 inside the cluster. If you're using Minikube, this is a great time to visit the service using the Minikube service command. Minikube comes with a bunch of helpful commands, which all are great. So if you do Minikube, let's clear the screen, Minikube service hello gopher. Hello gopher is the name of our service. It just kind of assumes the same name. And you can see we have visited the local machine on that port, which was dynamically assigned, and it prints hello gopher. And we can do /alligator, and we'll say hello Mr. Alligator. You can also go here and see everything that's being displayed currently. Great! So kubectl get all displays all the information. Now we're going to modify this, and we're going to start by deleting the whole deployment. So kubectl delete to delete, then follow that by, if you do this, it will tell you that you need to specify the resource. So kubectl delete, and we want to delete a deployment. If we only want to delete the service, we would do service, etc. So delete deployment hello gopher, and kubectl get all. If we do that, you see we only have the service running. Kubectl delete service hello gopher, because that was manually created. The service was not created using the deployment. Let's delete that. We created the service when we told Kubernetes to expose that port. So when we delete the deployment, we only delete the resources that was specified in the specification, and we had not specified a service yet. We're going to do this soon. But just so you understand what's going on and why you still see the service being here. And when you delete the deployment, you say, Kubernetes, I don't want anything in this deployment to exist. And that includes the replica set, the pods, and everything. So we have a clean Minikube cluster. Let's talk a little bit more about the labels before we move on. When working with Kubernetes, you will often see labels. A label is a key value pair that you assign a resource. And labels are often used to attach information onto that resource, such as, it can really be anything, deployment, staging, version numbers, anything that you can use to identify that certain resource. But you can do more than just identifying them and keeping track. You can actually use label to target certain resources that are tagged with that matching label. And this becomes really useful when you're using the kubectl command, because if you want to delete certain stuff from a deployment but not the whole deployment, etc., you can use the labels to target said resources. So you can add labels in the YAML files, but you can also add labels at runtime if you're testing stuff. So we will try adding a few labels just to get a feel for it. So we can do kubectl get all, and get all we used before, you can see here. So we have nothing running. So let's create the cluster again. I just told you to remove it, but now I want you to create it. Practice makes perfect. So kubectl get all will show you that we have a cluster running. If you remember, in the YAML file we added a label. So let's see if we can fetch that label. We can use the get all command, but we can add the option show labels, and this way you can see what labels our pod has and our service down here and stuff like that. You can also do, if you want just for a certain resource, you can do kubectl get, but instead of all you define the type. So it can be deployment, it can be pods. In our case, let's do the pods. And you can do show labels. The show labels flag is basically available for most arguments. So let's create a new label. We want to label our pod with the author. We can add that, and we'll be doing that with kubectl label PO. PO is a way of telling Kubernetes that we're working on a pod. Basically, it's the same as saying pod, but we're using a pod now. And you will insert the name of the pod. So you need to copy the full name of the pod and put it after PO. And then we specify the label to add. Author Percy. So let's go ahead and do that. And you can see that that pod has been labeled. So if we get pods again, you can see that the label now appears. So that's perfect. Sometimes you want to update the labels, and let's say we have a new author, it's Iron Man. You have to add -- overwrite. If the label already exists, you have to overwrite it instead, otherwise it won't work. So you see author already has a value, so do overwrite, and bam, we have now added or updated the label. And the same thing goes if you want to remove a label. Say that we're actually done with the whole author thingy now. You can do a author minus, and it was unlabeled, so it removed the label for us. So that's pretty good to know that you can modify these labels depending on what you want and what you're working on currently. So whenever we're using labels in the command line, we're targeting them by using selectors. So let's say we have the label app. So the application is Hello Gopher for our pod, right? And we want to find all the pods that are part of the application Hello Gopher. So we can do kubectl get pods, and you add the selector, and you say that app should be equals to Hello Gopher. Oh, we got the pod. So a label is called a label, but when you're searching for it or targeting it, you're referring to it as a selector. So you can also use negative values and a bunch of other syntax cool things. So you could do this instead to tell it, well, the app should not be equals to Hello Gopher, and you see that there's no resources found. There's a bunch of other stuff you can do here by using the selectors, but these are the most common ones. You can even use regex and stuff, but you can come a long way by using equals or not equals to. Now, getting resources based on a label to find them is great, but imagine if you have a giant cluster of resources, and at that point labels become very important. Also, they become very handy when managing resources, and you need to target multiple instances with the same command. So let's try deleting all the pods that are tagged with app equals Hello Gopher. Let's clear it, and we can do kubectl. I should mention that almost all commands accept the -- selector. So you can use it on get, you can use it on delete, on create stuff. So let's do kubectl pods. We want to target pods, and we want to use the selector. You can also use -L, which is shorthand for selector. And we want to delete all the pods that are labeled with app equals hello gopher. And you can see that the pod was deleted. And another thing about Kubernetes that is cool, which is one of the reasons why you want to use it. If you now get all the pods, you should see that, hey, the API pod is still running. But if you look at the ID, you can see it's not the same. Because let's make this clear now. We have deployed a deployment saying that we have a replica set and you should always have one pod running. Always have that one pod running. If we delete that pod, the replica set will go and say, hey, I don't have a pod running and I should have one, so I'll create one again. Kubernetes, wow. I mean, that's amazing. To delete this pod, you had to delete the deployment. Remember that. So I've seen people actually deleting pods and thinking, okay, we're done. And they get created again. So that's something you need to keep in mind. One of the selling points in Kubernetes is application monitoring. And we can monitor our applications using probes. Probes are used in Kubernetes to monitor endpoints such as TCP connections, sockets, gRPC endpoints, statuses inside the containers, etc. We usually talk about 3 probes in Kubernetes. We have the liveness probe. Sometimes also I've heard people mention it as the alive probe. But liveness probe is used to check if a container is alive or not. If not, it will try to restart the container. We have a readiness probe, which basically checks that the container has started up as expected, and when the container is ready to be used by other services. And we have the startup probe, which is used to probe a container until it is started. Now, I know it all sounds like they are the same thing sometimes, but imagine this. You have a container starting up, but it is slow. It takes a long time to start this container. Then, concurrently, you have a liveness probe checking an endpoint. So it sends a request to your endpoint saying, hey, are you alive? And it returns a 500 because there's no endpoint started. Then the liveness probe will say, oh shit, the API is down, we need to restart this container. You have an endless loop of restarts. So using a startup probe will disable the liveness and the readiness probes until the container is successfully started. And then it will enable them. We will actually implement probes to get more familiar with it and learn how we can leverage it. So we will start by creating a super simple readiness probe. We will add a probe that probes the wrong port, and the port will not be exposed by that pod. When we add a probe, we need to define in the YAML how it should probe the Kubernetes resource. The most simple probe is using a HTTP probe, and that fits our purpose also because we're using an HTTP API. We'll tell the probe to expect a 200 response back. So let's update our YAML file to define this readiness probe, and please note that I'm going to use the wrong port. So in here, inside the containers, because we want the probes to apply to all the containers, so they should go inside the template containers. And the way to define a readiness probe in Kubernetes is super simple. Let's size this up even more because some of you might be on mobile. So let's do a readiness probe. Boom. And a readiness probe needs a initial delay seconds field. And this is the time to wait before it starts probing. This is the time that, maybe your application is starting up, you don't want to start probing it right away, like poof, start. So let's say It should wait 5 seconds before it starts probing. And then we have a timeout seconds, which is how long to wait before a successful response is returned. Let's say that if our API doesn't respond within 1 second, then we are not ready. Then we need to configure how to probe. And we do it by using a HTTP probe. So HTTP GET, we're sending a GET to the path of /. This should be a path, either you customize a certain path like /ready, or you have a open, like our path, it should just return, right? So we don't need a certain one for that. And we define the port to use. We're using the wrong port, so we have added the readiness probe. It will wait before starting to send readiness. It will time out after 1 second, and it will shoot for the wrong port. So let's go ahead and save this file. We can go to the terminal and let's do kubectl delete deployment hello gopher. I want to delete the old deployment. And we will recreate it. Create f hello gopher. Right now we are deleting the cluster all over, or the deployment over and over. You can update it, and we will cover that shortly. So we have created a new cluster. If we go ahead and do kubectl get all, you will see that the pod is running, but it's not ready. Do you see here? Ready? It's a running pod, but it's not ready. And you can also see that on the replica set. It's not ready. Basically, this is telling us that it has deployed the container successfully. It booted up the container successfully, but it's not ready to start accepting traffic. And we can check this out by doing kubectl describe pod and copy the name. Boom. Describe is used to print a lot of information. Oh, sorry. Pod should be pod. Describe is used in Kubernetes to print massive amounts of information about a certain pod. You can see a bunch of information being printed. You can see the IP address, you can see what ports we have running, if we have any mounts, and you can also see information here. It has a readiness probe that polls this URL, which looks massively wicked, and information. You can see there's 1 success and 3 failures. The important part I want you to know is the event section. Events is events about the pod. You can see what kind of event it is. You can see the message and where from it comes. So you can see that we have normal, it's assigned the pod, it pulled the container and it created a container, started it up successfully, and then it starts printing a warning event. It's unhealthy because the readiness probe has failed. This is expected, but these events can help you debug and find what's going on inside your pods and really make your life a lot easier when you're trying to figure out what's wrong. Just for fun, you could go back here and change it to 8080 if you want to, and you could kubectl delete hello gopher. Let's redeploy it. Deployment, and we redeploy it. Clear kubectl get all, and you'll see soon it will wait 5 seconds. Remember, now it's ready. So it waited 5 seconds, the endpoint wasn't responding. After 5 seconds it starts to send requests and goes into the ready state. So we have a readiness probe checking if our API is ready. Let's take a look at liveness. Liveness works the same way as the readiness probe, but it's the probe that runs after the API is up and running. So readiness during boot up, liveness, everything's up and running, like default monitoring, right? So we can test this really easy. We're gonna add a probe, a liveness probe, and we're also gonna update the Golang server to start returning a failure after 10 seconds. Then instead of deleting the deployment, we'll start updating it. So we'll cover those. The liveness probe is exactly the same as the readiness probe, except it has one extra field, and that's the failure threshold. You can expect a container API sometimes to fail, maybe. Networking issues, anything. And you don't want it to kind of go all panicky on you because it failed once. So you can tell it how many times it's allowed to fail before restarting. So let's add it. Instead of readiness, you go ahead and do liveness probe. You do the same values, initial delay, how long should you wait? Let's say 5 there as well. Timeout seconds, and let's time out after 1 second. After 1 second, it will count as a failure. And then we have the failure threshold, which is how many times it can fail. Let's say we're allowed to fail 3 times. We're using a HTTP GET probe. We're using the same path, and we're pointing to the correct port. And this time, let's make sure we use the correct inline. It looks all messy because of this warning. We will fix that later. Don't worry about it. So we have liveness probe, we have initial delay, timeout, everything looks great. We will need to update the Golang code also. Before we do that, let's delete the service that's already deleted. Let's delete the deployment. So go into the main code. So let's start a timer at the beginning. When the API starts up, we will collect the time. This is the current time, and we will use this endpoint because this is the endpoint that we're probing, so that's the one we will use. We will calculate the time since startup so we can know when we start failing. So time.now, subtract the time since we started, we have a duration. So if duration in seconds is bigger than 10, we will log.println timeout triggered. We will set the HTTP header to status internal server error, and we will respond with a byte array saying hello gopher, I guess. And we will remove that and say else. We can actually set something else here. We can say I'm timed out, and we do write header status OK in case it's less than 10 seconds, and byte hello gopher. So what we added is a timer since we started the API. We calculate each request how long we have been running, and if we've been running for more than 10 seconds, then we will start timing out. And that's fairly simple. So let's go ahead and build it. Rebuild the Docker with the new code, and let's bump the version to 2.0. So we have created the 2.0 image, and let's go ahead and recreate the cluster. It created the hello gopher. Now if we do get all, we will see that very shortly it's ready. The pod is up and running and it's ready. It took 5 seconds because the readiness probe needs 5 seconds. But it's working. Oh! It won't stop working. Because Sorry about that, I messed up. This one is working because we didn't actually tell Kubernetes to use version 2.0. In here we say that each pod should use version 1. But we can update this to version 2.0. But before we do that, let me show you how we can do it inside the terminal. We can do kubectl set image. Okay, I just need to clarify that. We deployed the new deployment, but we didn't update the image in that deployment, so it's using the old one. So we need to set the image. We set the image of deployment hello gopher, and we are saying that the hello gopher containers are going to use programming Percy hello gopher 2.0. It has updated the image. So kubectl get all, it will show you that this is one thing in Kubernetes. It won't remove the old pod before the second one is ready. So as you can see, the second pod is up and running. The second pod is running, so the first pod was removed, which is great. So Kubernetes kind of handles that seamless for you. You won't ever... It's to reduce downtime, right? Don't remove the old deployment before the new one is up. It kind of makes sense if you think about it. We can see that we have it up and running, and you can see that the restarts are now starting to increment because the time has been passing, and as time passes, our container starts responding with a failure instead. Our probe will now start monitoring this to see that, okay, this is not good. Boom, it's not ready, and it has 2 restarts now. So our Kubernetes is actually now handling this error for us. There's some kind of bug in our pod, a memory leak, whatever. After a certain amount of time, it stops working. The liveness probe is detecting this and restarting the pod for us. In this example, it might seem ridiculous, but it can be really super duper helpful. Let's go ahead and do a change here. We don't want to use version 1. We want to use version 2, and we don't want to use kubectl set image. So instead of deleting the cluster in the future, we will be modifying the YAML file and reapplying that. And it's super simple. You will do kubectl apply the same way you do create, basically. So apply dash file, we want to apply this one. Right. You'll see a warning that this resource is not the original resource and that it is changing this for you, basically. So the next time you apply, it will just work. You can ignore that warning for now. And again, you can go ahead, you can keep checking the status if you see it keeps restarting basically until something's wrong, you know. You can also, if you want to, check out the events for the pod to see what's going on and why it's failing. You could do a describe on that pod. And when we do this, we will see that it's unhealthy at first, and then it's unhealthy using the liveness probe, and then it's killing it because it needs to restart. And it will keep doing that forever. What we've done now only kind of touches the surface of what you can do with probes. You can configure them and add much more, but a simple endpoint checker can get you very far very quickly. When our software fails, restarting, if you worked in IT, it's kind of a joke. Have you tried restarting it? But it's actually a very efficient solution most of the times. Restarting it might solve the problem, but there's often an underlying reason why it's failing. And debugging and finding out what's going on inside a pod can be useful. So the most common approach is to dive into the logs. You can find logs for pods using kubectl logs and then the pod name. Right now I have no logs. So if we do kubectl get all, it's because it's not ready and we have a new container. So if we check it, okay, now we have it and it's ready. We can do logs. You can see that a timeout has triggered. kubectl logs allows you to view the logs. One annoying thing is that our pod keeps being recreated, so the logs are reset. To avoid our pods from keeping to crash, really recommend us to recreate quickly. Let's recreate this, set it to version 3. Let's go in here and say that we should only time out after 1000 seconds. We won't be needing the timeout anymore, so let's update it to version 3 and set it to 1000 seconds so we can debug it a lot easier. So we have updated it to version 3, we have built it. Let's go ahead and do kubectl apply. It applied and we won't have to avoid the timeout all the time. You can execute into a pod, which is super useful. And you can execute commands inside a pod using the kubectl exec. Exec allows you to not only execute whatever binaries you have inside the pod, but it allows us to open a terminal if your container contains bash or ash or any other shell scripting. So using kubectl get all to view the currently running pod. And then we can do we can copy that name, and then we can clear the screen and do kubectl execute. We can zoom in so you guys also see. kubectl execute -it for interactive shell. This is the same as Docker if you're familiar with Docker. And then the command to run. We want to run /bin/sh. Now we're inside the pod, which is great because now we can start moving about the container and finding anything that is wrong. One very common error in Kubernetes is the killer. Killer is an event that is triggered, or an error. It is known as error code 137. And this is an error that occurs when your application runs out of memory. This happens because a node doesn't have enough memory to maintain the application. And if your application exceeds the memory limits assigned to it, it will restart and it will keep restarting until it exceeds the limit again. So regular memory leaks could be saved by a restart, but if the application really uses more memory than it is allowed, it will kill the container. So in Kubernetes you can configure the memory allowed to be used, and we will look at that shortly. When we're on the topic of debugging, I'd like to point out that there is a UI that exists to use to monitor and control and administrate your Kubernetes clusters. It's the admin dashboard. The dashboard can be found in the official documentations on how to install it. Minikube adds the possibility to run it as an add-on, and you can do Minikube add-ons to see, and Minikube add-ons list to see a list of all the add-ons that are available to add to the Minikube cluster. And if you do Minikube add-ons enable dashboard, you will see that the dashboard is being enabled, and you can also, it will even tell you that for some features you need the metric server. So while you're at it, do Minikube add-ons enable metrics server. So once you've done that, you can actually open up the Minikube dashboard by typing Minikube dashboard. It will pop up your browser and show you a UI. So this is the Kubernetes administrator UI. And this dashboard is really nice because you can use it to keep track of what's running and how your cluster is doing. You can see the CPU usage, memory usage, and just overall nice things. And you can visit the pods and see more information about them. This is basically the describe, but in a nice, more accessible way. Especially if you're not a terminal hacker, you can use this one instead to kinda see what's going on. I know some of you like UIs, so I just wanted to show you that real quickly. So right now we're running a cluster with a single deployment that has a single pod. Most of the time you'll have multiple deployments for your whole application. We're going to get some hands-on practice by adding a new MySQL database that runs that our Hello Gopher application can connect to. And we will be doing this step by step so we can explore services inside Kubernetes. Services, I think I mentioned before, are used to expose pods to other pods inside the same cluster. So the first thing we're going to do is adding a new deployment that runs the MySQL container. For now, we will keep it really simple with hard-coded environment configurations, but don't worry about that, we will look into that later. So for projects, I kinda like to separate things, so it's a nice standard. So in my folder, I'm going to create a new folder called Kubernetes, which is where I will store all the Kubernetes YAML files. Because they are not related to the rest of the project, but we can contain the whole infrastructure in a separate folder. I'm also going to create a new file called database YAML, which will be responsible for all our Kubernetes objects that are related to the database. There's a few different ways you can structure this. You could use a triple dash to kind of have more objects in the same file, and we will look into how we can do that right now. So let's begin by filling our database and using a MySQL. As before, we start with the API version, which is needed for everything, and we're going to create a new deployment. So I cheated a bit and used the deployment command, which kind of gives you everything. We don't want to do that. You can do that when you are familiar with it, but right now I think it's better if we do everything manually. So we're going to give it a name of MySQL. And since it's a deployment, we need to provide the spec. And the spec is going to have a selector, and we want it to be a match labels app MySQL. And the strategy for this one is going to be recreate. We will have a template. Same as before, template will have metadata, and the metadata will be the label app MySQL. Boink. Template should have the spec again for the containers. This is exactly the same as before, so you should be familiar with what's going on. We specified the image. The image that we will be using is MySQL 5.6. We will name it MySQL. MySQL requires a few environment variables, so you can specify that by doing env. And env accepts name key values. So the environment name we're providing is MySQL root password. This is related to the MySQL Docker container, so that's why we want a password for it, so we can log in. We're just going to put the value as password for now, which is really bad, but it sorry, let's fix the formatting here. So, oh, my bad. Sorry, we should boink, boink, boink. Now we're talking. So we have a container, we have the image, we have the name, we have the environment. Oh yeah, sorry, we have to index that. And we are going to expose ports, and it's going to be a container port of 3306, which is the default MySQL, and we're going to set a name for it into MySQL. It's going to complain that we don't resource limit it, which allows the database to take as many resources as it wants from the host computer. But we will fix that soon. So this is exactly the same as the Hello Gopher. We basically changed the image to use, and we changed or added a environment variable. This is very bad practice. Don't set passwords right in the file as this. So let's apply this. Let's add this to the cluster. And we can simply do apply F and point to the Kubernetes folder, and it will run everything inside the Kubernetes folder. So it says that the Hello Gopher is unchanged, but it created the MySQL, and we can go ahead and check it, and we see that everything is running. We have a MySQL pod. We can actually execute into it. We learned how to do that, so let's try it out to see that the database actually is working as we want to. So we copy the name and we execute into the pod. We do it interactive and we do bash. So we can now use MySQL, and we say that we are user root, and we know the password is the value of MySQL root password. And we're inside the database. So setting the environment variable worked as expected. We're not going to do anything in the database, so we can simply leave it. We now know it's working. One of the current issues we have right now is that the first pod or deployment, the Hello Gopher, cannot reach the MySQL. To do this, we need to apply a service. Services are used to allow access between pods or the outside world, and Kubernetes will handle setting up an IP address and the DNS name for the pods, and the service can also allow you to have the load balancing. The first steps to resolve so we can connect is actually placing the two pods in the same namespace. We haven't talked about namespace because I didn't want to mention it in the beginning. Because that would probably be confusing. By default, Kubernetes uses the default namespace. It's actually named default. So our pods are running in the same namespace, but we want to control the namespaces we use, because that is a way to isolate different parts of the applications into different areas. We're going to create a new file, because we're going to create the namespace using the kubectl command as well. And now I want to show you this, because the database and the Hello Gopher will want to be in the same namespace. We have to control the order of which the files are being applied. Right now it just selects both files. We can tell Kubernetes to select the namespace file first by naming it 00 underscore, and then whatever name we want. Let's call it namespace.yaml. We are creating a new Kubernetes object, and it's of the kind namespace. And the metadata that we will be adding is simply the name. The namespace will be called Hello Gopher. We can now tell Kubernetes that before we apply this, the database is supposed to be ran afterwards. So we name it O1 underscore. This is a naming convention that Kubernetes has to control the order of which it applies the objects. We're not exactly done here yet. Let's rename Hello Gopher to O2. Before we begin, I mentioned we needed a service. Let's add the service, and we can do this in the same file. Before we do it, let's go to metadata, and we want to change the namespace. So in the namespace of the deployment, because we want to change which namespace the deployment is in, we say that the namespace is now Hello Gopher. And then we can go down to the bottom, and here we want to add a new Kubernetes object in the same file. And you do that by delimiting the objects by triple dash. Like that. Now Kubernetes knows a new object is coming. So again, API version 1, kind. This is a service. and the metadata will be name MySQL. Namespace will be hello Gopher, same namespace in this for this object. We set the specification, and the specification for services are different. So for this one it wants a port, so we specify that the port 3306 is the one we want to expose, and we use a selector app MySQL. This is not a label. This is a selector inside of the YAML file, but it works the same way as a label. So we're not telling this template to expose the 3306 to other pods, but rather placing a label on this one and telling it that all objects with a label named app with the value MySQL will have this service attached. I hope that makes sense. We set a label which we can use to target these containers, and we tell the service to target those by doing this. We now have changed the namespace. We have added a service to target the container running the database. We also need to add the namespace to the hello Gopher deployment. And once we've done that, we can go ahead and do reapply to update them. You can see the namespace is unchanged. Okay, I've created that before, so that's why. But you should see that it's created and that the resources are changed. If you do kubectl get all, you will see that we have a few of them running. If you don't see any of the resources, it's because we are using the wrong namespace. So by default, you're using the default namespace. You can do kubectl config set context -- current -- namespace equals hello Gopher. What we do here is that we change the context or the namespace that we are currently working in to hello Gopher, because that's the namespace that we want. If you do kubectl get all, you should now be seeing everything that is running inside this namespace. You can try it out. You can set namespace 123 and then get all, and you should see there's no resources. So make sure you do this command so that you are working with the correct resources. Usually, if you're in a context, it will be automatically applied to that context or namespace that you have set. But I find using namespaces very common. So usually you can have multiple namespaces and stuff in the same project. I like placing it in the metadata so that it's easier to understand and know what namespace is being used. We have a service that we created, right? So we created a MySQL and a hello Gopher service. So we can actually do Minikube service hello Gopher, and we can specify with -n the namespace to use, which will open up the hello Gopher. It's important that you use the -n hello Gopher to visit when using Minikube in the future. So let's update our hello Gopher pod so it can connect to the MySQL pod. Now, one thing we should talk about is the service discovery. There's two ways. Either you can use core DNS as a service inside Kubernetes. You can also use the built-in service discovery mechanisms that comes. So when each pod is created that has a service attached, it will actually set a few default environment variables that can be used to reach that service. This requires the service to be created first and the pod afterwards. but you can use that using the things we did before with OOs, with the naming conventions that we mentioned, which we did. Right now, when you deploy it, you should see a service for MySQL. It gets created first. I can show you. I haven't set any environment variables for that container, but we can execute into it it --bash. Now we're inside the pod. There's actually a few environment variables, and they will be prefixed with the name. We named it MySQL, so it will be MySQL, and then it will be service_host, for instance, and this is the IP address that our pod has inside the cluster. And this is really useful because we can use these variables to reach the service, and these are applied to all pods. So even the Hello Gopher pod will have these environment variables set. So we can leverage that to connect to the MySQL service. You can find all the environment variables in the documentation that are created, but basically there's one for the port, there's one for the TCP port, the service name, and the service host. So host port and TCP port, which is great. So because that's all you need usually. Then the password and stuff you have to take from a secure way. So we'll look into that soon. Let's update our Golang code to connect to the database. It's pretty simple, and I will be creating a new file called mysql.go. To begin, we will start out by creating a structure that will hold all the configurations that we need. And we will need a username, we will need a password, and we will need a host name. We will need a port in the string, as a string. This is just to handle the environment variable easier. And once we have a struct, we need a function which can return this structure filled with the correct configs. So let's create a get database config, and it will return a database config object. Now we will have two environment variables automatically set by the service, which is the host name, which we can get by doing the service name. If you change the name, you have to replace the first part, _service host. Remember, Kubernetes sets this for us if your service is created before the pod. And secondly, we want the port to use. So we will copy that, use the port instead. Now, we also want a username, password, and a database to use. So we will also get those. These will be manually set. So we will have database username. We will have two more, which will be password, and we will have the database. And we will change this environment variable, and we will use name, database name. Right, and we will return a object filled with these. I guess we could make it even better by doing this. So let's fetch the environment variables, and we will replace it with the password. We will use the DB name. I think I named that one. Like that. We will use the host name and the port. Right. We can simply return that. So we have a helper function who returns the configuration. And we also want to create a DSN to connect. So DSN is the connection string used to connect. And we will actually accept a skip db boolean. We will talk more about this later. And we will call our getDatabaseConfig because we need that to create a connection string. So if skipDB is used, we will return a string formatted in a certain way without the database name. It will be the username followed by the password at we will connect through TCP and the host there, and we will use a second one. So that's how the string will be formatted, and do it like that. So let's do dbconfig. We will use the username. dbconfig. We will use the password. For the second string, dbconfig, where we will use the host name. For the database, we will leave it empty. And if we don't skip, we will return the same string, but instead we will fill in the database name. And we will save. Now when I save, it automatically imports, so if you haven't set up your IDE, you don't get confused. Right, so we create the DSN. Right, so create DSN is used to create a DSN with or without the database name. We're not using the port because we're using the standard MySQL port 3306, so you don't need that, but you could add that if you want to. We need to connect to the database. So we can create the connection string. Let's create a global. I don't like doing this, but let's create a global connection. Database connection. It's going to be a pointer to a SQL. And let's create a function that does connect. Connect database. And it will return an error because things can go wrong. So first of all, let's print some logs saying trying to connect to DB. And we will accept an DB, and we will do SQL.open, and we will use the MySQL driver, and we will create the DSN with true. We will use the database name. And if we receive an error, we will simply return that error with failed to open MySQL connection. We will wrap that error. I'm not sure how familiar you are with Go, but what we're doing here is we receive an error. Basically, this one is throwing an error, and we're wrapping it with a custom error, and then showing the underlying error as well. So we have a database connection. We want to assign that to our global variable. It might be that the database doesn't exist. So let's create a small function that will actually create the database if it doesn't exist before we continue with the connection. So function create database, which accepts the database name as a string and returns an error. Creating database. So we will begin by setting up a context with a timeout, because we want to cancel if this takes too long time. And we will wait for 5 seconds. So if it hasn't finished in 5 seconds, it will actually cancel. So let's go ahead and do the database connection, begin transaction. We pass in our context to make sure that we are using the timeout, and whatever error we get, just escalate them upwards. So let's execute with a context, and we execute, and the query we want to execute is create database if not exists, and we will format that with the database name passed into the function. Again, if we get any errors, we will simply escalate it upwards. You could wrap it. In this case, I'm just making it super simple. We want to check if we have any rows affected. If not, again, escalate the error. If the number is equals to 0, then we will return a custom error, because we have no error to escalate, so we create one. Failed to create the database. For some reason we got that failure, so we want to finally commit the transaction. And we want to say fail to commit tx, and we want to wrap our error. If everything is successfully done, we want to return nil. So in our connect database, we can go ahead and execute the create database, because we want to do that in case this is the first time we connect. And into the function, we will get the environment variable passed into the database name. And this is shorthand syntax in Go for error checking. If your function only returns one error, you can do it like this instead of this. Right, so we have connected, we have created the database. We will try to ping the database, because connecting to the database doesn't actually execute anything, so we have to ping it to make sure that it's actually connected. And then again, let's make a quick hack to avoid troubles. So let's open the database connection again, and we want to pass in false this time. Connection using database name. This is just if something goes wrong, or if we don't have the permission to create the database for some reason. We're not the root user maybe, and the database doesn't exist. So let's just make sure we actually got it connected to database. This is not the optimal way to do this. This is just a quick hack to connect. So we are ready, I think. We can connect to the database, and we can probably try that out. We need to actually execute this inside the main also. So go into the main file. We need to actually execute the connection. And we can do that simply by adding up here, connect database, error not equals nil. If that happens, we want to print a fatal error. And when we close the program, we want to tell the database connection to actually close. Defer in Golang is a way of saying that when this function closes, execute this function. So that's pretty nice to handle these kinds of things. So we're connecting and we're closing the connection as we shut down. Great, I think this looks good. So let's go ahead and update our code to OP version 4. Rebuilding the Docker. Everything built successfully, so there's no errors in the compiler. Now, before we can run this, we actually added a few environment variables that are needed. It's the database, username, password, and the name. So we can't run without these. These ones are automatically created, but these ones are not. We will be going into the Hello Gopher YAML and assigning these environment variables. They are hard-coded, and we will add it to the container template. So go inside Hello Gopher, go into the containers. We can put it after the ports, for instance. And we open up a environment section. And inside environments, we will be creating a list, and it's the key value list, same as before, but this time it's simply name, the value. The database password should be the same as we set in the database container, of course, so simply password. Username, the value is root. How do I need to tell you to not use root in production? Probably not. We pass the database name, we set the value to test. Let's call it test. So now we have updated the Hello Gopher to have hard-coded environment variables. So we can reach them as long as we redeploy this. So let's go ahead and reapply it. You can see that the deployment for Hello Gopher was configured because we added we changed the binary, for instance. Let's go ahead and see kubectl get all. We should see what's happening. So everything is up and running. We can try executing into the MySQL pod, because if everything worked out right now, we should see a new database called test. And if we look into the Hello Gopher logs, oh, sorry, my bad, I know. I did not update this. We didn't change the Docker version. So change the Docker version to 4 also. So I'm gonna go ahead and do that. I'm gonna reapply. See, it is configured, perfect. kubectl get all. We are having a crash loop back off. So a good time to actually look at the logs for this one. See what's going on. So we can see that we're trying to connect, but we failed to open MySQL connection. It's an unknown driver, MySQL, forgotten import. You know what? That's true. My bad again. Go inside the MySQL code. We actually need to import the driver for MySQL, which I forgot to do. Lucky us, we can execute kubectl logs to see what was going on. So let's go ahead and add the import for MySQL driver. The underscore here means it's a silent import. So we're not actually using this import, but rather having it execute init method. In Golang we have a method called init, which will execute and do stuff. We need to do that to register the MySQL driver. So once that's done, I'm gonna rebuild the Docker image. We're gonna see that it actually did not like that. And we can do go mod tidy, and we can do Docker build again. And now it worked. So it downloaded the driver. We can go ahead, kubectl apply. And we can go, so we're using the same version here, sorry. I'm gonna rebuild it again, but version 5 this time. I'm going to update this to version 5 in the Hello Gopher, and I'm going to reapply. Now it changed. Now let's clear kubectl get all. We should see that it is soon to be running. So now it's running. It's not crashing anymore. And if I do print the logs, we can see trying to connect, connected, and it's connected. Sorry about that miss. I can't believe I forgot to actually update. Execute the pod, it, and --sh. We're inside this one, so let's go ahead and check out the database. I'm gonna do password, show databases, and we have the test database being created. So our Hello Gopher container or pod is actually connecting to the database correctly and creating the database for us. So we have connectivity between two pods. Great! Let's continue on. So you might have noticed that we're using hard-coded passwords in plain text. And this is not good practice, I'm not gonna lie. Kubernetes allows us to handle configurations and secrets using something called ConfigMaps and Secrets. And you can find more details in the documentation about it. You should use configuration maps whenever you have non-secret values and secrets when you have sensitive information, such as the password. So let us go ahead and replace the environment variables that we have specified with a configuration map solution instead. To do this, we're going to create a config map. And you can do this either from something called a literal, which is a text string, or you can use a file, which is delimited by new lines. If you have multiple environments, I really suggest you use a file for it instead. So I'm going to go ahead and do that. I'm going to open my files here, and I'm going to create a file inside of this, which will be called dbconfig.properties. And inside of it, we can specify database user is root, database name is test, for instance. We can go ahead and use this property map to create the configuration map. So inside the terminal, you'd go ahead and do kubectl create config map database configs. This is the name. So we create a config map called database configs. We want to do it from from env file dbconfig.properties. Now I already have that created. Let me delete that. So I've deleted the config map, and now I recreate it from the properties. .properties is a well-known format, and it's used in Kubernetes, so it's very simple. As you saw, it's basically property key equals value, new line, and so on, so on. You can view all your config maps, which I should have done before showing you guys, by doing kubectl get config maps. And you can see that we have database configs. We have 2 data entries, that's 2 configs. And you can also view more information by config maps and then output format YAML. If you do output format YAML, you will see detailed data about the config map, and you can actually see the data points. Now, to use a config map that we have created like this inside of the Hello Gopher YAML, we are going down to use a config map reference instead. And config map references is used in Kubernetes to tell Kubernetes that it's supposed to take data from the config map. It's pretty simple. So let's go ahead and do that. So we will leave the database password as is, because we won't handle that using a config map, because it's secret. So we will do value from instead of value. So replace that. And value from will accept an object. And that's going to be a config map key reference. And config map key reference accepts the field name, which should be the name of the config map. So database configs. And then we specify the key. And it's the same as we put in the file. So we're saying that the containers should have a environment variable named database users. It will get the value from a config map reference, and the config map is named database configs, and the key to use or take the value from is database username. We will go ahead and do the same for the database name. Actually, I'm just going to copy paste this and print it in and replace the username with name. Like that. Right now we have used a config map instead of hard coding the values inside the YAML file. You can try applying this. So it's as simple as doing a regular old apply. And everything should be working again. Right. And now it's running the pod and it's not in error state. So that is amazing. This is a big improvement, but we still have the password and we need to look at that. I want to address an issue before we look at the secrets though, and it's, as you can figure out, if you have super many environment variables, pretty tedious to keep writing each of all these. Like if you have 20 environment variables, this is going to become very, 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 very long. We can actually remove this again, because you don't need to do that. So remove the environments that we set, and instead we're going to use something called env_from, which actually pulls in a whole environment map instead of specific values. Above inside the template for the containers, above environment, I'm going to place env_from, which is another key which instead accepts full configuration maps, and it's going to be a config map ref. I'm showing the first way because it's not always that you want all the values. Maybe you have a configuration map with many values that in this particular microservice isn't used and you only want one or two of them, then you can do it the other way. But if you have massive or well-structured configuration maps, this approach is a lot easier. We're specifying that the containers should all have the environments from a reference to a config map named database configs. This will work exactly the same as we did before. You just have to remember that you don't have the ability to rename the environment variables inside the container, which we did before, but we don't now. Now it will use the same name as we specify here. But to avoid repeating all the environments, that's a pretty nice solution. Again, if you want to, you can redeploy to just make sure that everything is working. I'm getting a lot of replica sets, I need to remove them. And bam, it's running and there's no errors. We have created a config map, but we have introduced a small weird dependency to that config map. If I send my YAML file to somebody, they won't know what the config map looks like, and that's bad. A very simple solution is actually you can create the configuration map inside the YAML files. So inside the database YAML, since the configuration map is related to the database, we will be adding it here. So go ahead, add triple dash again to delimit a new object, and the API version, guess what, it's version 1. The kind this time is a config map. And we can place some metadata. We can say that the name is database configs and the namespace is hello gopher. We can also easily specify the data fields, database, username, and some default environment variables. So this is actually the most nice approach, I think, because now the users that accept the database YAML will know what the config map looks like. So this is really the best way. I just wanted to show you that you can create them manually, but preferably you should create it inside here to expose to the other developers what you need in the environments. You can see this as a way of kind of documenting. You can delete the old config map. kubectl delete config map. And I can again apply the Kubernetes. Everything's working. Now it's time for the final piece, which is secrets. The password, we can't have it plainly like that. We will be storing it as a secret. Luckily for us, this is done the same way as config maps, but instead we use a secret map. Secret maps aren't really that secret inside of the cluster. It's base 64 encoded values. The point is not to encrypt the secrets. What we can do is, first off, we want the base 64 value of our password. So we will echo password, and we will pipe that into the base 64 command, which will output a base 64 string of the password. We will be using the base 64 value to store it in a secret map. The same way we did create a config map, we can create a secret map. We can go ahead and do a new object, API version 1. The kind is a secret, and the metadata should be the same. Database configs and namespace hello gopher. The type should be opaque, and the data should be database password. Again, this serves as a documentation for what secrets your service will need. Don't put the real secrets here. This should be default values, only serving as a documentation for what you need, and creating the appropriate fields. They should be replaced in production. Can't stress that enough, I guess. So we have created the secret map. Now we also need to change when we retrieve the configuration. We can actually do the same thing as we did before. We can go ahead and do a value from, but instead of a secret map reference, we will use a secret key reference. So value from, it's not going to be password this time, it's going to be a secret key ref. We're going to specify the name of the secret, which is database secrets, because we named it that, right? Secrets, database secrets it should be. We can then database secrets, we can set the key to be database password. Now this will fetch the value from the secret instead and place it into the environment variable of database. So that's very, 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 very nice. Once again, if we clear kubectl apply f Kubernetes, we will see that the secrets is created, and we have configured the deployment for the hello gopher. So we can get all, we can see very soon that it will be up and running again and no failures. You can view the secrets by doing kubectl get secrets. You can see that we have database secrets and database secrets. This is probably me creating the wrong one. Did I misspell? In the hello gopher, I misspelled. Database secrets should be. And the other one is from when I created the tutorial. So you can also, again, same as before, go ahead and do output it as YAML, and you will see that it's base 64 encoded. Now you're thinking, okay, we've added a secret, but it's still kind of plain text since it's base 64. Well, you should replace the secrets, of course, when you deploy to production. And you can do that easily by using the patch command. Actually, Kubernetes comes with a command called patch, and you can use that to patch a secret. So we can target the database secrets, and you can say that we want to patch the type, and we're going to use JSON, and then you can insert a JSON object with the secrets that you want to patch. The JSON accepts a JSON object. In our case, we're only replacing one, but each of these objects accepts an operation, and the operation we're running is replace. You specify a path, and the path is /data/ the name of your secret, so database password. Then the value. And we can replace it to test. This should be base64, but just to show it. And if we run that, you can see the secret has been patched. You can do this to update your secrets in a CI/CD pipeline easily. Because then you could build your JSON with the real secrets in the pipeline and patch that into the secrets. So before we conclude this small tutorial, I want to address a simple important aspect that we haven't yet touched. Right now you've seen my editor blows up with all red blobs. It's basically screaming at me that something is wrong with your containers and it's the resource limitations. Right now our pods are free to use whatever resources on my computer they want. They can use all my memory, 100% of it. We don't want that. You don't want that in production. A simple API as this we can limit to ridiculously small amounts. There's no point in it needing this. Now there are two types of setting that you need to be familiar with. There's the limit and there's the request. The request is the minimum available resources on the worker node that needs to be there and provided for your worker to be selected as a valid node to host the pod. If a deployment says all these containers need 1 GB of memory and a worker only has 500 megabytes, it won't even try deploying because it's not fulfilling the request. Then there's the limit. The limit is the maximum amount of resources that the pod is allowed to use. But unless you specify anything, the default is infinite. So it can use as much as it wants. You can watch what your pods are using by using the famous top command. You can do kubectl top pods, and you can see here what they are using right now. As you see, the memory is very small for the Hello Gopher API. So we can add limitations to the Hello Gopher pod just to try and see how it's done. The Hello Gopher is very simple and it doesn't need a whole CPU core, so we can limit that to 0.1 cores. Often you will see numbers such as 500M, which represents 1.5 CPU cores. To get 0.1 CPU cores, we set the limit to 100M. It's a expression way which you can read more about on the Kubernetes resource docs. So let's go ahead and limit it, and it's really easy to add limits. So let's go ahead and open the YAML for Hello Gopher. Go to any place that we want to be. We can go right after the ports just to keep going. We do add resources, and inside resources you can specify the limit and the request. So we're going to specify the request limit. For any node to accept these pods, we have to have at least 1 megabyte memory. We need to have at least a really small amount of CPU, and we want the limit to be tenfold, and we want the CPU to be double that amount, which is equivalent 100M is equivalent to 1.1 CPU core. So if we add this, the IDE stops complaining and we have now limited, so this doesn't spin away. In case there's a memory leak, or whatever. I think that's everything for the basic limitations that you need to know. It's really depends on the service and the API and the kind of deployment on how much you need, of course. You can kind of use top to figure out how much it's draining, and so we won't cover how you can actually debug what is draining what. So this kind of concludes the tutorial. We have been covering how we can configure a simple Kubernetes application, how to run it on a local node using Minikube. We have touched on the basics of Kubernetes, and you have learned how to set up pods and replica sets and deployments and services and what they are. And hopefully you found it good enough to start using Kubernetes and start exploring more. You can find the final code for this little tutorial on my GitHub. I will put the link in the description. Hopefully you've gotten a bit more familiar with Kubernetes. I do recommend Kubernetes the Hard Way by Kelsey Hightower. It's a superb but much harder tutorial. Deploying Kubernetes to production is a whole nother tutorial of its own. I can recommend you to start googling on kubeadmin and kops to get familiar with some of the tooling that is regularly used with Kubernetes. One other way to deploy Kubernetes is using managed services on Google, AWS, or Azure. They all provide managed services for Kubernetes, which I personally recommend. Maintaining a Kubernetes cluster is too much work for me. I hope you enjoyed. I hope you feel free to reach out with any questions, feedback, or any tips for the future on how I can improve my tutorials. Hopefully you will like and subscribe this video so you will see more from me and I will see more from you.